Today we're going to start our new unit on forces of motion. It's also called Newton's laws. This unit is all about physics, and it's all about how things move through the world. So we're going to be talking a lot about energy, and we're going to be talking a lot about force and forces. So let's dive right in. First, we're going to go over our 10 vocabulary words to kind of get us prepped for this unit. Then we'll identify the 4 important words that we need to start knowing right now. And that'll be it. All right, so let's get started. So looking at our vocabulary words. First one we have here is gravity, right? We all know what gravity is. We experience it every day. It's what keeps us from floating off in space. The important thing to know is that gravity is a non-contact force. All right, so gravity is a non-contact force that causes objects with mass to attract each other. So basically anything with mass has some amount of gravity. We don't feel it because almost everything is too small. It takes something very, very, very big with a lot of mass for us to be able to feel the gravity. We're talking something, it takes something literally the size of a planet for us to feel gravity. What's important to know is that gravity is a non-contact force. Gravity does not have to be touching you for you to feel the force that is giving off. All right, number 2, force is a push or pull that causes an object to move, stop, or change direction. All right, so a force is anything that causes something to move, right? Any force that causes something to stop, like I just did, or a force that causes something to change direction, okay? Number 3 is motion. Motion is a change in an object's position. This is very easily described as movement. Anytime something is moving or has been moved, it shows motion, right? So if we set this right here, no motion. As soon as we cause a change in position, all right, now the pencil is in a different position than it was, that was motion. That was movement. Even if we do something so simple as that is still motion because there's a change in position. So that was number 3. Motion is just any type of movement. Now, number 4. This is where we really need to get into these definitions because these 4 words, 4, 5, 6, and 7, are day 1 information. These next 4 words, I'm looking at you because it's serious. These next 4 words, you have to know. You will access this information. You will use these 4 vocabulary words in every science class we have for the next 3 weeks. All right? So starting now, we're going to focus on them big time because these are super, super important. And they're pretty easy to understand. Starting with number 4. So 4 and 5 go together. Number 4 is balanced forces. Number 5 is the opposite of that, unbalanced forces. So balanced forces occur when forces are equal, they cancel each other out. So balanced forces do not cause a change in motion. What that means is, I have my hands here, I'm going to push them together, and I'm going to push them, I'm going to push with my right hand with the same amount of force that I'm pushing with my left hand, right? So you can't tell, but I'm pushing pretty hard with both hands. Why can't you tell that I'm pushing? Because there's no movement, right? I'm pushing with the exact same amount of force with this hand as I am with this hand. So once they push evenly with each other, these forces pushing this way and this way are balancing. They are balanced forces. They're equal. And so they cancel each other out. So we don't see any motion. We don't see any movement. But if we go down to unbalanced forces are when forces are unequal. The strongest force determines the direction of motion. Does cause a change in motion. So if we bring our balanced forces back, putting our hands together, pressing them evenly, so I'm creating 2 forces of equal magnitude towards each other, right? So remember, these are balanced forces because nothing is moving. The forces are canceling each other out. But I'm going to use this hand and I'm going to push this way a little bit harder than I'm pushing with this hand. So here we go. We're pushing in. All right, right now we still have balanced forces, but as I increase the pressure with this hand, now we see movement. All right, so this hand is pushing stronger, so we're seeing the motion being controlled by this force, which is what it's saying right here. Right, when forces are unequal, the strongest force is the one that determines direction. So since I was pushing stronger with this hand, we see motion this way. So the easiest way to remember it, anytime something is still and not moving, it is there are balanced forces acting on it because there is no change in motion. The opposite of that, whenever something is moving in any way at all, there are unbalanced forces acting on that. Right? So unbalanced forces is showing that there are movement. And a way we can do this, I'm going to take my cup. Let me use this. I'm going to take this little clock. I'm going to set it here. Now, gravity all right, so this clock sitting here, gravity is pulling this down, right? Gravity wants this to go down. So gravity is one force that is pulling down on this clock. But the clock isn't falling. Why? Because there is a balance of forces acting on this clock. So for all the effort that gravity is making to pull this clock down, this table is here stopping it. So the table is actually pushing up against the clock as gravity is pulling down on the clock. And we don't have any movement. This clock is not falling to the ground, which is no movement, which means these forces are balanced. As hard as gravity is pulling down, this table is pushing up. So the forces balance and cancel each other out, so we have no movement. If I were to pull this off here, now gravity is pulling on it, and if I were to let it go, if I were to let this go, obviously it would fall, right? Because we are creating unbalanced forces. If gravity is pulling this down, and I'm not holding it with my fingers to counteract gravity's force, then we will have unbalanced forces. It'll be only gravity pulling with nothing pushing back up or keeping the clock here. So when it's only gravity pulling, when we have an unbalanced force, is when we see movement. So an easy way to remember it. Balanced forces is no movement. Unbalanced forces is movement. Okay? Next two words. 6 and 7. These are also paired together, but they're also opposites, and they are also synonyms with what we have going on up here. So these two words, potential energy and kinetic energy. The word potential means we're not doing something right now, but we could do it later in the future. The word kinetic literally means movement or motion. So this word means moving. This word means it's not going on right now, but it could go on later. So potential energy is the energy stored in an object that is not moving, okay? And kinetic energy is the energy of something that is in motion. So how we can look at this is, use our clock again. This clock is not moving, okay? It is not moving at all. I'm going to sit on the edge that says, this clock is not moving, right? So what this clock has is potential energy. The clock is not moving now, but we know that it could move later. And especially if we see that it's on the edge of this desk, right? If a force acts this way, right? That's movement, kinetic energy. If a force acts this way, that's movement, a little bit of kinetic energy. But which way would cause the most amount of kinetic energy? Which would cause the most movement? If we push here onto this edge, we know if we keep pushing, eventually this clock is going to tip and it's going to fall, right? So if when something is sitting still, it is not moving, but it could move later. So we call anything sitting still, anything that is sitting still, we say it has potential energy. It is not moving now, but it can potentially move later. Now, the opposite of that is our number 7 word, kinetic energy. Kinetic energy, like we said before, is the energy of something in motion. So this has 0 kinetic energy right now because it is not moving. This has a whole lot of potential energy, but it has 0 kinetic energy. But as we move it, I am now turning this potential energy, where it's still, I am now converting potential energy into kinetic energy. Because remember, kinetic energy is motion. If we have motion, then we know that we have kinetic energy. All right? So anytime something is still, it's potential energy. Anytime something is moving, it is kinetic energy. So let's review these 4 words really quick. We can kind of pair them up. All right, so think about it. Looking at these definitions, learning what we learned. 4, 5, 6, and 7. Which 2 of these vocabulary words would mean no motion or not moving? So pick 2 of these vocabulary words that mean no motion or not moving. Balanced forces do not cause a change in motion, so that means no motion. Potential energy stored in something that is not moving. So we can pair balanced forces and potential energy together, because both of these mean that there is no motion. If there are balanced forces acting on something, that thing has potential energy. Or if we can say something has potential energy, it's because balanced forces are acting on it. All right, so which 2 can be used to describe something that is moving or is in motion? Well, it'd be the other 2. Number 5, unbalanced forces, and number 7, kinetic energy. Unbalanced forces does cause a change in motion, causes movement, kinetic energy. The energy of something in motion. So kinetic energy deals with movement, and unbalanced forces deal with movement. If something has kinetic energy, it is because unbalanced forces are acting on it. So, not moving, not moving. Moving, moving. All right. Know these words starting now. Last 2 words we're going to talk about is friction, then speed, and then inertia. So friction is a contact force that acts against motion. This pencil that I wrote this with, this pencil uses friction to write. Right? Best way to experience friction, put your palms together, make a fire. Rub, 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 and you'll feel that heat. That heat is a result of friction. Right? So friction is just any contact force that acts against motion. So gravity can cause friction. Air can cause friction. When you are playing basketball, what keeps you from sliding all over the court is friction. If you're playing football or soccer, what keeps you from sliding all over the field is your cleats have those little spikes on them. Those spikes help increase friction. All right, so friction is just anything that acts against motion. Speed, very simply put, is the rate of motion. It can be described as distance divided by time. Similar, if like when we say in a car we're going 15 miles per hour, the distance, miles, divided by per time, right? Hour. So 15 miles per hour. Same way we can say that. Last one, number 10, we're going to talk more about later, but we're going to go ahead and introduce it right now. This word is inertia. Inertia is an object's ability to start and stop moving. Another way we can say this is an object at rest wants to stay at rest, and an object in motion wants to stay in motion. Think about it this way. Think about, basically this says if something is sitting still, it wants to stay that way, right? And it will stay that way until another force acts on it. If something is in motion, it wants to stay that way. And it will stay that way until another force acts on it. So, the force acting on this pencil to keep it from staying in motion is going to be gravity pulling it down and friction between the table and the pencil. So, another way we can think about inertia. Think about these words. An object at rest, right? At rest means not moving, and in motion means moving. We can think of this kind of like, think of inertia kind of like you when it's time to go to bed, right? So when you wake up in the morning, we can say you're at rest. Like when you're sleeping, you're resting. So when you are at rest, you want to stay at rest. When you wake up in the morning, do you want to get up? Heck no. You are resting and you want to stay at rest. You don't want to start moving. Now, the opposite of that, once you finally get up and you go about your day and you get out of school and you go home, you're watching TV, eating snacks, playing some games. When you are in motion, doing all those things, you want to stay in motion. So what happens when you're playing games and then it's bedtime? You don't want to go to bed because you're in motion and you want to stay in motion. Objects are the same. If an object is at rest and not moving, it wants to stay at rest, just like you do. If you're at rest, you want to stay at rest. If an object is moving, it wants to stay that way, just like you do. If you are in motion or you're doing something, right, you don't want to start resting. You're busy, you're up, you're doing stuff. You want to keep doing things. Objects are the same way. And that principle, that concept is called inertia. All right, so those are the words discussing those vocabulary words. Use the information in this video to complete the balanced or unbalanced quiz. It is 24 questions. You have to label, you have to read each statement. And for the first tip, in part 1, you have to decide if each statement is a showing balanced or unbalanced forces. In part 2, you have to decide whether each statement is showing kinetic or potential energy. And in part 3, you just have to match some vocabulary words to the definitions. It is all on, the whole page is on these 4 words, okay? So start learning them now, because you will be using them every single day. All right? Cool. Next video will be on our Slinky Science Lab. So we'll see you.